school or not?
Yeah, there will be a monthly test this week.
Okay, perform well in that, right?
Inshallah.
Inshallah. Okay, so let's start with basically we were at the topic of light, and I hope that in the light we will be done with lenses today, inshallah. And when we will be done with the lenses, probably the topic would be in your grip. Okay, so in light, I was at lenses. Okay, Ariba, did you ever hear the word lenses?
Yes, sir. I'm wearing lenses on my glasses, and I've worn lenses before.
Yes, glasses. Okay, which type of glasses do you wear? Converging or diverging?
I'm sorry?
Yes, what type of lenses do you have? Did you ever notice down that when you are throwing light on your glasses, they are going to spread the light out, or when you throw light on the glasses from your mobile, mean those glasses make the single spot of the lights. Did you ever
Yes,
notice this now? What do they do?
they reflect the light.
Oh, really? Yeah, yeah. Do you use glasses?
No,
No.
I know what
Okay.
converging diverging means.
Yes, but you now
I hope.
diverging and converging means, for example, if Ariba is using that glass which I have made at the top, and this one which is at the bottom, let's say, I will shift it over here. So Ariba will see that light is focused on a single point, like this. Spot would be formed over here,
Mm.
right? So Ariba, as I told earlier in my first lesson, that light consists of beams and rays, and we have the parallel light rays over here. These are actually the parallel light rays. So when these parallel light rays are bent, actually they are bent. They bent in two ways. One, they are converted into diverging beam. Okay, isn't it diverging beam? And this one is your converging beam. The light rays are converged. So this is your converging beam. So this is basically changing the path of light. Isn't it that? Don't you believe this thing that it is basically changing the path of light?
Yes, I mean we do.
Is it
I
not?
do. Yes.
Yes. So this is called refraction. So Ariba, my question is still there. I will be back to your glasses. So lenses, the part of any sorry, any translucent material, translucent material which is used to or which is used to bend the light. Bend the light. Okay. So
So
Ariba,
our optical cables lens.
yes, that is called a lens. That device is called a lens. Now,
Okay.
Ariba, my question is, do you have a long sightedness or short sightedness?
I'm pretty sure I have long sightedness. Like if I'm looking at something from far away, I can't read it. But if I'm
You
looking at some
cannot read at the board, right?
yes, if I'm far away, I cannot.
Okay, so you have short sightedness.
Right,
Okay,
okay.
right? I mean to say that if you are unable to see the far of distance objects and you are pretty good in seeing the nearby objects, your short sight is good. That's why you are having a ability of seeing the things at nearby distance. So this is called short sightedness. So when you are having this problem that you cannot see the far off distances, you use a converging glass in front of your eyes. Oh, sorry, diverging glass in front of your eyes. So when you throw light through mobile on that, it will basically spread that light out. It will give you a shade like this, spreaded shade. You have to test this one. एक dark room में जाओ after class, not like this. Mean not like right now. Then throw light of mobile on your glasses. You will check that the light is spreading out. So this is what this is the main identification that where we are having diverging lens or converging lens. But if someone is having a problem seeing or reading the book, right? For example, you cannot read the book. So what will you have? You will have a converging glass in front of you. So it will focus your light or focus your eyes over here. So this is called long sightedness. You can see the board, but you cannot see the or you cannot properly read the book. So this is your long sightedness. Okay, this is what long sightedness. Anyhow, this was just an additional detail. This is not of my topic right now, but I will talk about the application area. I have started from the application area, and then I will be back to my topic. That what type of lenses do we have? Types of lenses we have. There are two types of lenses. One is called converging lens, and second one is called diverging lens. Okay, one is converging lens, and second one is called your diverging lens. Okay, are you getting it? Converging lens is those it focus the light at a single point. It focuses the light at single point. Light at a single point. Okay, and what about the diverging lens? It spreads the light out. It spreads the light out. Spreads out the light actually. Now, this is called convex lens. In your daily or commercial level, we call it a convex. Okay, it is a convex lens, and this one is your concave lens. Okay, what do we call it? Concave lens. Why do we call it convex? Because it has this type of shape. It is thicker from the centers and thinner from the edges, and this one is called concave because it appears just like a cave from the middle. It is thinner from the center and thicker from the edges. So this is that line. So technically, if I throw the light on this one, what will it do? It will focus all the light at a single point, and we call that single point the principal focus of that lens. What do we call that point? That is your principal focus of that point. Okay,
Was that called the focal point? I mean,
yeah,
that's what
focal
it's
point
called.
as well, exactly, right? So the point where light is focused or light appears to be spreading out, where light is focused by any converging lens. Converging, I'm talking about converging lens first. Converging lens is called a principal focus, okay, or focal point. Principal focus or focal point. Will you remember this thing? You are asked about focal length, define focal length, right? What is being asked? Define focal length. Is it clear that focal length is the point where all of the light goes to be focused at a single point? This is your focal point, or we can say principal focus. Okay, is it clear to both of you? Is there anyone else who joined me?
No.
Hassan? Nahi aaya Hassan. Okay, go back to the point. So when I will throw the light on this diverging lens, actually I will yeah, it will see, or it will appear that light is coming from a single point, and that is that point, single point. This is called its principal focus, because I'm looking right from front of the lens. So I will say that, oh, light is coming from this, or light is emerging out from this point. So that is f over here. Now this is the center of the lens, right? What do we call this? This is the optical center. What do we call this? Optical center. Optical center is basically the center of the lens, right? Will you be able to understand that? That optical center is center of the lens. Now you are asked about focal length. I told you that that is in our syllabus, that define or state what is focal length. Focal length is represented by small f, and it is the distance between, this is the definition of that, the distance between focal point and optical center of the lens. Optical center of lens. Is it clear?
Yes.
Okay, so if I say, when we represent the lens, representation of a lens is just with the help of a straight line along y-axis. Representation of a lens. Usually, lens is drawn properly, but sometimes what do we do? We draw a straight line. This is called principal axis. What is the name of this? I will just remember. I will just draw all these principal axis. This is the main axis along which the light is supposed to travel, and this is a straight line which indicates the direction, sorry, position of a lens, right? But instead of this, what do? Usually we draw a curved lens like this. It seems to be difficult sometimes. We cannot draw it properly. That's why we just draw a straight line, vertical line, right? So that is your lens. Got it? Now I will draw 2 points. I will mention these 2 points. This is principal focus or focal point of your lens, and this is your C. And this distance, what I was talking about, the distance between this point to this point is your focal length. Is it clear now? This is your focal length. Is it clear, Ariba and Yahya?
Sir,
Yes.
I'm confused.
Where?
What is I don't understand the part about the axis and the
Axis is just like your x-axis and y-axis. So your x-axis is called principal axis, right?
okay.
And this is your y-axis actually. So this y-axis shows the position of the lens. So if I say that I am going to draw that in terms of x-axis and y-axis, let's say, so x-axis shows your direction of wave, or sorry, direction of light, and y-axis shows the position of your lens. For example, this is your x-axis and this is your y-axis. So you can simply say that, okay, this is lens, and this is basically let me draw it straight if it could be. Yes, so this is your lens, okay, and this is your axis. Simply say it is axis, not, it's not a big issue. Okay, now the light ray travels parallel to the axis before the lens. What happens? All the light rays, they travel parallel to the principal axis before they enter in the lens, right? So this is the center of the lens. This one is the optical center. Now after this, they all will pass through F. Remember this thing. What will happen? These all light rays would pass through F. So it means this central line will straight move straight. It will not bend. This light will bend and it will pass through the principal focus this way. Okay. What about this light? It will also pass through the principal focus this way. So all these lights are supposed to move or pass through principal focus or focal point after the lens. Is this clear? These are
Yes.
called rays. So Ariba, you got it now? Okay, why did I use this axis? That I use this line as a reference. That where are the parallel lights, or what is the direction of the light? Okay.
Okay. Okay.
Okay.
Thank you.
Right after that, we have ray diagram for a lens. This is very important. Ray diagram from a lens. So actually, we are having converging lens. So we are going to draw that we are having this converging lens through converging lens. Okay. So there are some points to remember. Point number one is that these are the rays what I use, right? I name these lines as rays. So use at least two rays. How much? At least two rays. Okay, to have an image or to form an image from a lens. Two are must. Why? Because intersection is required, and after intersection you can get where the image will be formed. Secondly, ray 1 must pass through optical center without bending. Must pass through. I will draw this, don't worry, and I will call it ray 1. So wherever I will write ray 1, remember this, that I am writing about that way. Ray 1 must pass through C. C means, what is C? Center of lens. Center of lens without bending. Without bending. Okay. Then rate at step number 3, you have to draw. Okay, let me write in this way. This is what this is, a zero method. You have to do this by all means. So let's say this is your ray 1, this is your ray 2. So you will not get confused that 1 is in front of ray 1 and 2 is in front of ray 2. So ray 2, before lens, it must be parallel to the principal axis. Before entering the lens, before entering the lens, it must be parallel to principal axis. Okay. And at third step, after lens, it passes through focal point. After lens, it must pass through, it must pass through F. Don't forget these 3 points. That's it. You will get a ray diagram. And Ariva, most of the time ray diagram is asked to you from the lenses. So I will draw that ray diagram for you. For example, if I have a lens, if I have a principal axis over here, this is the axis, which is basically my reference axis. And here is the position of the lens. Let me mark some positions over here. Actually, I had a presentation, but why I don't use that? Because when I will draw in front of you, it will help you out. It is 1 2 3 centimeter away, 1 2 3 centimeter away. Okay, so here I marked some positions, 1 2 and 3. So this is the optical center, I mean center of the lens. So just I will draw a straight line over here at 90 degree to this one. So this would be considered as length. So let's say this is your lens. Okay, 1 2 3 4, 1 2 3 4 lines above and 4 lines below that. This is your lens. Okay, is it clear, Ariba? This is what, this is position of your lens. I told you that if I show in this way, this is your lens. Now this is your principal focus or focal point, this is your principal focus or focal point, and so on. Now let's have an object placed over here. Where? Over here. Okay, where is the object? It is anywhere beyond F, principal focus. So what I told you, Ariba, this is very important. Yeah, yeah, as well. Yeah, yeah, are you there?
Yeah, yeah.
Okay, so what I told, you have to draw a ray number one from the head of the object passing through the lens without any bending. This is your ray number one. Ariba, did you get this ray one?
Yes, sir.
Okay. Now, what about ray 2? I told you about ray 2 that it must be parallel before it enters the lens. Before it enters the lens, I have to show that it is parallel to principal axis. So I have to make this 0 0. Okay, now it is parallel to principal axis. So this is what, this is your ray number 2. Ray number 2. So then what I told you about ray number 3, that after lens it must pass through F. Yes. Are you agreed? Should I draw it now?
Yeah.
Yes. This is your ray number 3. What is that? This is your ray number 3. This green one was ray 2 and this was your ray 3. So this is compulsion, not an optional point, that this ray must pass through this, right? And you can use third one as well, but I told you that at least two are required. At least two are required means that if this is a light ray which is coming from before the lens in this way, it would become parallel to the principal focus after. So you have to use those top one twos जो मैंने draw किए हैं. You can draw this one as well, this one, but no problem at all. This will give you the same point of intersection over here. So that's why what I told you, that no need to get worried about this ray. It gives you the same position of intersection. So out, how many rays can you use? Either green or blue or green or black. Okay, what is the set? Either green or blue.
Why not blue and black?
You can use that, but sometimes point of intersection get problematic. We do not get point of intersection equal at the same point. That's why. So it is easy to use these two.
Okay.
Okay, it is very easy to use, or to, you can say, accurate to draw an image through this. So either green or blue, or green or black. So usually we use which one? This one. This is not green, sorry, green and blue. This is not R. This is and. We need two. So what do we use? We use that green and blue. Most of the times we use that. Okay, now where the image will be? Yeah, yeah. At
Will be
this
on
point.
the
Yes,
intersection. Yeah.
where they are intersecting Actually, this is what, this is the position of the image. So this is what, this is usually called the image. Oh, this is your image, right? This is your image. Is this diagram clear to all of you?
Yes.
Actually, what is the mystery behind that? This is your candle. Okay, this is your candle. So that candle is lit at this point, the light is coming out of that candle, and here you will observe the same candle but inverted. This would be difficult for me to draw the same candle. Okay, I will try, but inverted candle. Oh, I did it. Yes, this is the candle over here. Is it clear to you? Mean the light source which is generating the light from here, that light source will appear over here at this position. Is this clear to all of you? Yes.
Yeah, clear.
Okay, then properties of image formed over here. So this is a very important question, formed by converging lens. That is, first set is the image can be real and inverted. The image will be, not can be, image will be, it is must. Image will be real and inverted. I mean to say, this is one set. If image is real, then it would be inverted. This is compulsion. I mean, it is must, right? If image is real, then it must be inverted. But if second set is image, I can write in this way, that virtual image will be upright. So you can write in this way that the real image will be inverted and the virtual image will be upright. So I can say that this is another set of image obtained. If that is virtual, then it will be upright. So I will write all these four properties over here. This is again a must condition. You cannot have any exemption over here. Yeah. अब मैं आपको बताता हूँ what is real image. It is asked to you, right? What is real image? Can you, can anybody tell me real image क्या होती है? The image obtained on the image that can be projected on the screen. This is first definition of that. The image can be projected at screen, right? That image which you can project on the screen is called your real image. Real image is basically which is obtained by the intersection of light rays, right? Is obtained due to intersection of light rays. Is obtained due to intersection of actual light rays. I will use a word over here. Intersection of actual light rays. So here we notice that the light rays have been converged, and those are passing or intersecting each other at a single point. So here we produce an image. So that's why it is called a real image. Okay, is it clear? Then we have inverted image. Inverted image mean which is on the opposite side of principal axis. Okay, the image on the opposite side of principal axis. The image. Oh, well, wow, I got another very important point. What is the main identification of a real image? Real image is always on the opposite side of lens. Yes, I remember that. कि real image आपके पास कौन सा होता है? When it is formed on the opposite side of the lens. This is your lens, right? On one side you place an object, and on the other side you will get an image. Okay, yeah, and Ariba. Real image is always, it is always on the opposite side of lens. On the opposite side of lens. I mean on the side opposite to the object. Okay. Then we will talk about the virtual image. Virtual image cannot be projected on the screen. Virtual image cannot be projected on the screen. Projected at screen. Right? This is first property of that, or first identification mark of that. Second, it will be on the same side of the object. It will be at the same side as that of the object. At the same side of lens as that of object. At that of object. I mean, object and virtual image will be on the same side. This is what I wanted to write. Object and virtual image will be on the same side of the lens. Is this clear? And it is generated, or it is positioned by dotted lines. Positioned by dotted lines. You draw those lines by yourself. Lines drawn by us. We draw those lines. Actually, light rays never intersect each other. Okay, and let's write a final benchmark for that. That it is in magnifying glass. It is in magnifying glass. Remember this thing. Magnifying glass. So whenever you will have magnifying glass, the image would be your virtual image. Now there are two other properties for the image. One is your inverted image, and second one would be upright. Inverted image क्या होती है या? Can you tell me?
It is like upside down or
Yes,
from
very good. Image upside down. I mean opposite sides of the principal axis. If image and object are opposite side of principal axis, then that image is inverted. If image is
principal
yes,
axis is vertical one, right?
yes, is
Principal axis is vertical one, right?
but no, principal axis is horizontal line.
Uh,
Is at opposite side of horizontal line, principal axis. Horizontal matlab x axis, principal axis, then it is called inverted. It is called inverted image. Are you getting this thing? Like this, if I will draw that, if this is an object and you are getting image over here, okay, this is your object. I'm not going to draw the line rays, but just showing you that if object is above the principal axis and image is below the principal axis, and if object is this one and image is over here, it can be on both sides. It's not that above and below. That's why I have drawn both of these over here. Then this is the inverted image. Are you getting this thing? I mean, the tip of the object will appear as the tip of the image over here. So this would be something like this, and it would be something like this way. You clear? So this is basically inverted image. I mean, its shade is this green shade is above where object is below, and this red shade is above on the object side where it is below on the image side. So this is basically, these images are real and inverted. Real and inverted. Is it clear to both of you? And then we have upright. Upright is on the same side of x-axis. If object and image are at the same side of principal axis, then image is upright. Okay, and this is in magnifying glass. Again, I tell you, it is in magnifying glass. Okay, then there are two other types of images. One is enlarged and diminished. Enlarged is when the image appears larger than object. What is enlarged image? When image height is greater than object height. Greater than object height. So that candle what I have drawn over there, was it enlarged or diminished, Ariba?
Sir, I don't understand what you're asking.
Okay, I'm saying that if the height of the image is greater than height of the object, so you will call it enlarged or
Yes.
magnified image. Is it? Got it?
Yes.
Okay, so the candle I have drawn in my first diagram over here, is it in magnified or I mean enlarged or not?
Sir, I'm quite sure it's a little bit enlarged, but I don't know if that was the.
Yes, exactly 1 centimeter enlarged, because the height of this object is 2 centimeter. Okay, and height of the image is 3 centimeter. So you can say that what is the magnification over here? That magnification is height of image divided by height of object. So it is 3 divided by 2. It is 1.5 times that one. So there are some lenses on that it is written 20x, 12x, and so on. So what is that? It is magnification. It means this lens is 1.5x. magnifier. 1.5 times it would enlarge the image. Is it clear to you?
Yes, sir.
Did you ever see that we use some scopes on the snipers or some toy guns?
Definitely
Yeah.
not on snipers, but on, I mean, on toy guns,
On
but like
toy
on
gun.
snipers.
Yes. So we use these magnification factor, that how much magnification will be there on this lens or this scope. This is that scope, and right here we use different lenses. For example, we use another lens of some different magnification factor over here. Okay, this one, its magnification is different. So actually, let's say it is 200x. So it means this would magnify the image 200 times, right? Usually we have 25 to 50x mostly, but we can use those. Okay? Is it clear? Oh, this was a broken sniper. Now, come back to the diminished. Diminished. What does it mean, Ariva? Diminished? उधर तुम्हारी अंग्रेजी ठीक है, बताओ जल्दी से। डिमिनिश का
N-
मतलब क्या होता है?
Well, the name meaning of diminished, at least what I know, it would mean like to go away.
Oh, yes, it is diminish, go away, get smaller.
Yeah.
So diminish means smaller, right? So if
Yeah.
the height of image appears smaller than height of object, then it is diminished or smaller. Then the
Okay.
image is called diminished or smaller. And you know where we used to have this property in our eyes and camera. Image is real, inverted, and diminished. I mean smaller. You have to remember this. This is very important. This is asked so many times. But in your magnifying glass, this is again an important point to remember. In magnifying glass, I will draw that magnifying glass image, don't worry. In magnifying glass, image is virtual, virtual upright and enlarged, or you can say magnified. That's why it is called magnifying glass. Got it? Okay, now let's talk about magnifying glass, how to draw the image in magnifying glass. Image formation in magnifying glass. Okay, ji? So let's have a magnifying glass. As I told you that it is a converging lens. Remember this thing, this is not a diverging lens ever. It is a converging lens. So if I have a converging lens over here acting as a magnifying glass, so I can say that it has the principal axis over here. This is the principal axis. Okay. So this is the glass. I will say that it is acting just like a magnifying glass. So where we have to place the object, this is very important. Then you will get magnification. our mean magnification will be decreased. So let me draw that at what distance I have spotted that. Let's say it is over here. Okay, this is the point, and then it is 1, 2, and 3 centimeter. 1, 2, and 3 centimeter. Okay, over here. Over here, there is a point, and over here, there is a point, right? Oh, yes, that's fine. Okay, I have 2 points over here. And Ariba, what do I call these points, by the way?
I think
Principal
focal
focus.
point.
Focal points are principal focus. And right, this is a optical center. Now, you have to make sure that object is placed in between F and C for magnification. When you want your lens to be used as a magnifier, a magnifying glass, you have to ensure this, that object is placed in between F and C. Now, draw a straight line passing through the lens, passing up through optical center without bending. I told you this is ray number 1. For ray number 2, what I have to do? Yes, yeah, yeah.
It goes through the F.
Okay, this is ray 2. It is
Yeah.
parallel, and now ray 3 would be something like this. It must pass through principal focus. So this
Mm.
is your ray number 3. Is it clear?
Yes, sir.
Okay. Now, are these rays intersecting each other, or they? It appears that they will intersect anywhere.
No.
Never. So, Ariba, what will we do now? I will put the scale at F and the point where it is intersecting the lens, and I will redraw this line, dotted line, or dashed line behind the lens this way. Got it? Are you getting it? And then I will do the same procedure for this line, this blue one, this one. Okay, this way. Are you getting this thing? I will I will just draw this line beyond the lens in this way, and I will check where the lines are intersecting each other. Here is my object. Sorry, image. This is your object, and this is your image. So I'm going to magnify this for you. So for example, if I say this is a small candle over here, this one, it would appear a larger candle, but not on the opposite side. Where will it be? बताइए. Yes.
So enlarge.
No, it is, yeah, it is enlarged, but that candle was basically over here, na? This was your object candle, this one,
Yes.
and this one is your image candle, image of the candle actually. So if I say that this is your image, and if I say this is your object, so what is the difference between this diagram and the diagram I have drawn previously?
In that one, the light is focused on the other side. Another one. In this one, it is spread around. Also, see.
Yes. Are you getting it? So here is the observer. When observer will see that, the observer will see, oh, it is a magnified image, right?
Yes.
Is it clear to you? This is a magnified image. So this is the way when you place this magnifying lens over here. Actually, you did nothing. You just put your magnifying lens over here. This is the handle of that magnifying lens. By this image or by this magnifying lens, you are seeing your image over here. So is this clear to all of you? I mean, both of you?
Yeah.
Okay. So uh, this is what this is all about, the image formation from a converging lens. In my next class, inshallah, we will discuss about some sort of questions. I can show you those questions right now, but probably you will not be able to handle these questions, right? Yeah, you can handle, sorry, you can handle that. For example, a converging lens is there. Ariba, do you have a class ahead right now?
I do in about 3 minutes, sir.
3 minutes.
Yeah.
Okay, so in 3 minutes you have to take water and so on. I will just discuss one MCQ with you. This is an object, this is a lens, and that lens is placed in such a way that you are getting image over here. So what is the nature of this image and what can be formed on the screen? And can it be formed on the screen? So what is the nature of this image? Is it real or inverted, real or virtual?
Real.
Real, because I told you that this is due to actual intersection of, sorry, this is due to the intersection of actual light rays. So non-real is gone, so this is real. So real image can be projected on the screen or not?
It can.
Yes, that's why I have written all those specs which can be asked to you. So that is the real image which can be projected on the screen. So here is the image which diagram shows an image of an object formed on the screen by a converging lens. So converging lens can form real and inverted image. That can form real and inverted image. Is it? Got it?
Yeah.
Okay. So here, can you see that which image is correct one? This will decide, this line will decide that whether the light passes through 2f or light passes through f.
Light passes
F.
through F. So
So
it's C.
yeah, it is wrong, it is wrong. So this is right, because l- I have told you that you have to draw two lines, one passing straight, second passing through f, not from 2f. So that's why this is that correct option. So is this is this clear?
Yes.
So these are basically the concepts what we use to draw over here. I have shown you all those concepts over here. I believe that it will help you out uh, when we will figure out the worksheet. Then it will help you out a lot. Any question you want to ask me? Yes, Ariba.
I don't think so, sir.
Okay. And yeah.
No, no question.
Okay, so when we will be doing worksheets, then basically we will have some sort of questions and we will discuss those, right? See you
Okay.
inshallah. Okay.
Yes, sir.
Allah
See you,
Hafiz.
sir. Allah Hafiz.
Allah Hafiz. Allah Hafiz.
Okay.
Allah Hafiz.